Stars are giant balls of hot gas. It is mostly hydrogen, with some helium and small amounts of other elements. Many stars produce more energy than the Sun. The energy source for all stars is nuclear fusion. In a nuclear fusion reaction, the nuclei of two atoms combine to create a new atom. Commonly, in the core of a star, two hydrogen atoms fuse to become a helium atom. Stars begin their life with fusion of hydrogen. So, what is hydrogen fusion? Hydrogen fusion is the fundamental nuclear reaction in stars. The two most important reactions that fuse hydrogen into helium are PP chain and CNO cycle. PP chain stands for proton-proton chain. For stars that have internal temperature less than 15 million Kelvin, the dominant fusion process is proton-proton fusion. This nuclear reaction is the reason behind the existence of every life form on Earth. After that, the CNO cycle. CNO stands for carbon, nitrogen, oxygen. The CNO cycle is another nuclear reaction which stars produce helium from hydrogen using carbon, nitrogen, and oxygen as catalysts. Moreover, for all the stars which are collapsing at the center, the temperature can exceed 100 million Kelvin and initiate the helium fusion process called the triple alpha process. Once all the hydrogen has been converted into helium in the core, the energy release is huge.
Why we choose this topic? We choose this topic because we want to get more information about how stars react in space and to understanding more about nuclear reaction. Here is a general methodology that can be used to gather information on nuclear fusion in stars. So first, we used to define the learning objective. By learning objective, we can start clarifying what specific aspect of nuclear fusion in star you can understand. This could be include the process involved, type of star where fusion occur, and energy generation. Second is utilize online resource. So we look online resource such as specific journal, education website, and UC lecture material. Okay. Third is use scientific database. We access scientific database like Google Scholar and search an article about the star and research a paper on the nuclear fusion in star. So this platform can provide the deep studies and the latest research about the nuclear in star. Next, we read books and publication. Okay, we explore a book written by astrophysicists and expert in the field of the nuclear fusion and stellar evolution. Okay, some recommended titles include an Introduction to the Modern Astrophysics by Bentley Will Correll and Dale A. Astol and Principle of Stellar Evolution and Nuclear Synthesis by Donald D. Clayton. Next, we watch a lecture and documentary. So we watch many educational platforms offer lecture and documentary as on astrophysics topics. Platforms like Coursera, Khan Academic, and YouTube can be available resources for visual and auditory learning experience. Next, we experiment with simulation. Some websites and software to provide simulation related to the stellar evolution and nuclear fusion. This simulation can help we visualize complex process and deep our understanding. Next, we consult with an expert. If I have a specific question and it's referring on a certain topic, so I ask about this topic for expert people about this field. Okay. Next, take notes and summarize. As we gather information, take details, note, and create summarize of the key concept Process and finding. Organizing your notes will help retain information and clarifying our understandings. So for the last is review and reflect. So periodically review our notes and revising challenging topic and reflect our learning journey. Consider how to the piece of information you have gathered fit together and depends your overall comprehensive of nuclear in the stars. By following this step and maintaining a curious and proactive approach to learning, you can develop a comprehensive understanding of a nuclear fusion in star through independent study.
Next, what is the challenges encountered and propose a solution? So, for the challenges encountered, nuclear fusion reactions in stars are responsible for creating most of the light elements up to iron. Heavier elements are produced in a network of nuclear reactions and decays, mainly involving the capture of neutrons by the unstable nuclei that only exist for fractions of a second. Therefore, it is also essentially impossible to measure the majority of these rates in the laboratory because of the unstable nuclei involved cannot be made into targets for irradiation with neutrons. Next, what is the challenges? Next, for the solution of the challenges encountered, an experiment was performed at the National Superconducting Cyclotron Laboratory, which is also called as NSCL, on the campus of Michigan State University, revealed that these challenging reactions can be conquered by an indirect approach that exploits the formation of unstable nuclei in beta decay and the detection of the gamma ray radiation liberated in the process with the sun detector. What are nuclear reactions? Nuclear reactions are a process in which one or more nuclides are produced from the collision between two atomic nuclei or one atomic nucleus and also a subatomic particle. The nuclides produced from nuclear reactions are different from the reacting nuclei, which is commonly referred as the parent nuclei. There were a few importance of nuclear reaction. Even though nuclear reactions are less numerous than chemical reactions, but they are basically essential in many aspects, which is they are the source of energy in the sun and also stars and the synthesis of elements in the universe. The nuclear reactions are becoming essential in human life, which is it becomes an electricity production from nuclear power plants and also a source of radioisotopes for medical imaging to visualize organs and to diagnose disease, to treat tumors and also a cancerous cell.
Today, I want to explain more details about nuclear reaction in star. So first is about energy generation in star. According to Einstein mass minus energy equivalency principle, so E equal to mc2. Okay, a small amount of mass can be transformed into a big amount of energy. This principle controls the energy generated during nuclear fusion reaction and the energy produced by the pp chain in the sun and keep it bright and allow life to exist on Earth. Second is about stellar evolution and nuclear reaction. Main sequence star mostly fuse hydrogen into helium when they are in the main sequence phase. The mass of the star determines how long this phase will last. Red giant phase. Stars grow into a red giant in later stage as a hydrogen in their cores run out. Helium fusion and the other process take place in this phase, result in the formation of heavy atoms like carbon and hydrogen. Second is about proton-proton chain reaction. The Sun and the other lower to medium mass stars undergo this initial fusion process. It entails converting hydrogen into helium in several steps. So for the last is carbon, nitrogen, hydrogen cycle. The mechanism which convert hydrogen into helium utilizes carbon, nitrogen, and oxygen as catalysts. Is the most common in higher mass stars, more 1.5 times the mass of the Sun. Example, nuclei in star have three. So first is the Sun. The Sun undergoes proton-proton change reaction in its core, converting hydrogen to helium and releasing energy that powers its luminosity. Second is red giant. These stars have exhausted hydrogen in their cores and are now fusing helium into heavier elements like carbon and oxygen. Third is supernova. Supernova is a massive star undergo successive stages of nuclear fusion, leading to the production of elements up to the iron. So the core collapse during a supernova releases tremendous energy and enables the synthesis of heavy elements through rapid neutron capture process. So this example showcases the diversity of nuclear reaction in stars and their role in the stellar evolution and element synthesis. Next, I would like to talk about the application in daily life. First, I would like to talk about the agriculture and food. Agricultural workers use radiation to prevent harmful insects from reproducing. When insects cannot have offspring, there are fewer of them. Reducing the number of pests and bugs protect crops, providing the world with more. Next, in medical, nuclear technologies provide images inside the human body and can help to treat disease. For example, nuclear research has allowed doctors to predict precisely the amount of radiation required to kill cancer tumors without damaging the healthy cells. Lastly, I would like to talk about the water desalination. Water desalination is the process of removing salt from salt water to make the water drinkable. However, this process requires a lot of energy. Nuclear energy facilities can provide the large amount of energy that desalination plants need to provide fresh drinking water.
Fusion reactions have proven difficult to control, and no fusion experiment had previously produced more energy than had been put in to get the reaction going. It was announced that a fusion experiment at the National Ignition Facility (NIF) at Lawrence Livermore National Laboratory in the US has achieved producing more energy than the laser pulse that was used to heat the fuel. The energy in the laser pulse was 2.05 megajoules, that is equivalent to the energy to boil 6 kettles of water. The energy from the fusion reaction was 50% higher than the energy of the laser pulse. It was released in the form of energetic neutrons.
Hi, there are several potential carriers related to the nuclear reaction in star reading in a modern physics. So first is astrophysics. Astrophysics studies the behavior is celestial objects, including star, through theoretical model, observation, and simulation. They investigate nuclear reaction in star, cell evolution, and synthesis of elements through fusion process. Second is about cosmologists. Cosmologists is explore the large-scale structure and evolution of the universe, including the formation and evolution of star. And they may study nuclear reaction in star as part of understanding the broader cosmic context. Nuclear engineering. Nuclear engineering work with nuclear energy, reactor, and reactor technology. So while the focus may be more practical than theoretical research, understanding nuclear reaction in star can provide insight into reactor designs and nuclear energy production. So next is astrochemists. Astrochemists study the chemical composition of celestial objects, including stars, and process that lead to the formation of molecule and element. Understanding nuclear reaction in star is crucial for explain the abundance and dispersion of elements in the universe. Is science educator. Educator in physics and astronomy play a vital role in teaching and communicating concepts related to the nuclear reaction in stars. So they may work in school, university, museum, or outreach program to educate students and public about astrophysics and nuclear physics.
What skills do I need to excel in this career? Soft skills like specialized skills and knowledge, technical expertise and problem solving are important to excel in this career. Specialized skills and knowledge is having a deep understanding of nuclear physics, reactor operations, and radiation protection. Furthermore, technical expertise, which is expert in analyzing nuclear systems such as core performance and fuel cycle processes. Move to the next point, problem solving. It is the most important skills that we should have. This is because we must possess the ability to evaluate risks and formulate innovative solutions to address challenges efficiently. Our proficiency in critical thinking enables us to identify potential hazards, propose effective safety measures, and optimize nuclear processes. Hence, mastery of this technical will enable us to effectively contribute to the development and maintenance of nuclear systems.
Next, for the significance of continuous self-development. In a world that is constantly evolving in the field of nuclear reaction, the concept of lifelong learning has become more relevant than ever before. Phenomena that involve a nuclei are important to be understood because they actually explain the formation and also the abundance of the elements, radioactivity, the release of energy from the sun and stars, and also the generation of nuclear power. To explain and also predict the nuclear process, two additional types of interactions that known as strong and also weak nuclear interactions must be introduced. They play a fundamental role in nuclei, although it is not at a larger scale because of their effects are very short range.
There are some challenges some physicists may face, which some of them are limited job opportunities, competition for positions, and difficulty securing funding for research projects. Other challenges may include the need to constantly update skills and knowledge, and a lack of diversity and representation in the field. There are also some strategies that they use to overcome all the problems by networking and building connections in the field. This can help open up job opportunities and collaborations. Additionally, staying updated on new developments and technologies in the field can also increase job prospects and funding opportunities.
Audio Jungle.